say it one more time what we made it
So
draw.
like, you know how you have x coming in from both sides, right?
Correct.
So let's say you shorten it from one side, you extend it from the other side. So
If I shorten it, what if I like move this dot over here?
yeah. So basically, so you.
Let me just make sure I understand what you're asking.
Yeah. How would you make that your new limit? If you
Like
have
that?
X yeah, because if x is both coming on both sides.
Well, it would be whatever is above it, I guess, or wherever it completes it.
So this is now back at 1, right? This is still a dot on the curve, right? It's a closed dot on the curve now. And there's a hole over here. So now, what's the answer to this? 1.
It would be 1.
Well, let's say this is now what?
2.
I don't care, 0.98 or something, right? This is negative 1, 0.98 sitting there. That's where that hole is that you're concerned about. So what's the answer to the limit?
It'd still be 1.
Still 1. I'm looking at what happens as x heads towards 0. In this particular case, I've chosen 0 for my example. So as x heads towards 0, the function is heading towards that spot, which is 1. But there's a hole here. What do I care? What, I mean, did I trip over to something? All I need is a tiny little window there where the function can head towards that value. Okay. And extend across the whole plane. Yeah.
Okay. So if you shift that up, like
5 units? 4 units to 5?
Okay, yeah.
So Cornejo wants me to do this. I could just place this one at 5 and erase that 5, but I'm just make it look like I moved it. Something like that, okay?
Yeah.
Pow, pow, and there's a 5, and there's a 0, something like that, yeah? 1, 2, 3, that's perfect. All right. So x, that's now a different function that's f of x plus 4, we'll just call it h. That's h of x. And now what do you want to say? What's the limit of h is that? Limit of h of x as x heads towards 0. Is that your question?
Yeah.
What's the answer?
5.
5. Oh, 5. Why? Because as x heads towards 0 from both sides, what is the function heading towards? I'm just riding the curve down to 5. It's heading towards 5.
Okay.
Yeah.
How about this x heading to negative 1 or 1 or 3 or something like that?
It would still be the same concept.
So you're just riding to the.
So let's take it. Okay,
It's
so here,
just
head towards 1.
wherever it's going.
Is where it's heading. Which is where it's moving towards. Where it can't quite end up. Limit of g of x. We'll use this one, and we'll use a different number now as x approaches 1. So what does this say now? It says, what is g of x, right? What is this function, right? These lines here. What is that function heading towards as x gets arbitrarily close to the number 1 from both sides?
Infinity.
Careful. X is heading towards 1. X is heading towards 1. What is the function heading towards? 1. Right? As x heads towards 1 from both sides, on the function, if you're writing the curve, right, it's heading towards 1, right? That's the g of x value, right? X comma g of x. As it heads towards 1, this is heading towards 1. That's where it's going. That's where the function is going. Yep.
What if it was actually x is heading towards 0?
Okay, good question. Let me answer another one right before that, though. Limit g of x as x heads towards negative 1. What is the answer? 1. 1. As x gets arbitrarily close to the number negative 1 on the x-axis, the curve is approaching from both sides. That value right there, that height, it's approaching that height. It has to be a closed dot, I don't care. It has to be a closed dot. It is the number 1. Now I'll ask you a question. What is the limit of g of x as x approaches 0? That was the asymptote we brought this in for the first place. Okay? What's that?
Infinity.
So already says infinity. Whenever it says positive infinity, well, that's just infinity. That's fine. Everybody agree?
Wait, what was the question?
What is the function heading towards as x gets arbitrarily close to 0?
Oh, yeah.
As x gets close to 0, the function is approaching what?
Infinity.
Infinity. Plus infinity. 0.
Positive infinity, yeah.
It's heading towards 0? It's heading towards this number right here. It's heading like, pow. It's heading down there.
Nah.
The function's not. X
You have
is.
to watch
X is
the
heading towards
function
0 along the
actually
x-axis
go.
on the side. But the function, writing the curve is heading towards as large as you want. Which some people call positive infinity.
Positive.
Okay? Is that a limit, though? The answer is no. It's not a limit. The answer to this, although we know it is becoming arbitrarily large as x gets very close to 0, this is not a limit. So you write D and E. Does not exist. Limit does not exist. Even though you can tell me where it's heading, a limit by definition is a number. You should remember that.
I have a question.
Yep.
Would you, are we allowed to put either infinity or DNE, or do we have to put DNE, like on the written homework?
I would put D and E.
All right.
If you ask me where it's heading, then you can tell them positive infinity or negative infinity. It's applicable.
Mhm.
But if they ask you, does it exist or not exist,
You would still say no.
Don't put an infinity symbol.
Yeah.
Put a D and E or something.
All right.
A limit by definition is a number. And you can find that value. So infinity, although again it is a direction something is heading, it is not a limit because you don't reach it, right? Not heading towards anything in particular. That's what it means to be a limit. You're heading towards something particular. Infinity is not a particular thing. You're just getting larger and larger and larger arbitrarily. Right? So the way the definition is usually written is, I'm just going to replace this a bit here. Erase the 0, put an A. Some number that x is approaching, A equals L. These are the symbols for a limit. L is a number. That capital L must be a number. That alter limit. It has to be a number. It's infinity, or negative infinity, or nothing at all. Doesn't have to approach anything, sometimes. The answer is D and E does not exist.
So can we say that G is 0 is D and E?
G of 0? Same thing, yeah, it does not exist in the function. Same thing, yeah.
Same
Same thing, yeah. You can write undefined for this as well. It'll be the same thing. It doesn't exist. Because the definition requires that it be a number, and so therefore, if it's not a number, then it is undefined from the definition. It's undefined. Just a quick aside though, since we have this other asymptote here. About that one.
0.
Who said that? Okay, knock them all out, yeah? And then 0. That's that asymptote, right? So x gets arbitrarily large as x. As x goes out this way as far as you want, right? X just keeps on trucking out there. What is the function doing? The function is approaching the x-axis, which is the number 0. It's approaching the number 0. Is this